Hello, and welcome to this seventh set of problems on arithmetic progression, numeric progression, and harmonic progression. So, without further ado, let's get started. As always, I'll say that when I read the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then you should look at the solution. So, let's get started. Problem 61 says that the pollution in a normal atmosphere is less than 0.01%. Due to leakage of gas from a factory, the pollution increased to 20%. If every day 80% of the pollution it's not us, is neutralized, in how many days the atmosphere will be normal? So each day pollution decreases by 80%, that is 20% pollution will remain. So the common ratio would be 20 by 100, that is 1 by 5. So if pollution is say 1% on first day, the second day it would be 1 by 5%, third day it would be 1 by 25%, and so on. But uh, for us, the initial pollution level is 20%. So we say that it takes n days for the population to become normal. Then first term into 1 by 5 to the power n minus 1 should be less than 0.01 because that is the normal pollution level. So n is greater than 4, so atmosphere will become normal on fifth day. Problem 62 says that the sides of a triangle are in GP and its largest angle is twice the smallest one. Prove that the common ratio of the GP lies in the interval 1 comma square root of 2. So we let AR and AR square be the sides of GP with R greater than 1. We let the smallest angle be alpha. Then according to question, the largest will be 2 alpha because the largest is twice the smallest. So apply the sine rule to the smallest and largest angle. We get A by sine alpha is equal to AR square by sine 2 alpha. That is sine 2 alpha by sine alpha is equal to R square. So 2 cos alpha is equal to R square. Now, since alpha is not equal to 0, cos alpha will be less than 1. That is R square less than 2. So R will be less than square root of 2. Therefore, the common ratio lies in the range 1 comma square root of 2. If ABCD are in GP, prove that ax cube plus bx cube plus cx plus d is divisible by x square plus c. So here we let R to be the common ratio, then b is equal to AR, c is equal to AR square, d is equal to AR cube. So ax cube plus bx square plus cx plus d becomes x cube plus ARx square plus AR square x plus AR cube, which is equal to a multiplied with x square plus r square multiplied with x plus r, and x square plus c is a into x square plus r square. So clearly upon division we will get x plus r, and thus we can say that x cube plus bx cube plus cx plus d is divisible by x square plus c. Problem 64 says that if a, b, c are three distinct real numbers and they are in GP, if a plus b plus c is equal to xb, then prove that x less than minus 1 or x greater than 3. So we let R to be the common ratio. So we get B is equal to AR, C is equal to AR square. Now A plus AR square is equal to XAR, that is R square plus 1 minus X into R plus 1 is equal to 0. Now since R is real, that is R is in the set of real numbers, D has to be greater than equal to 0. That is 1 minus X square minus 4 greater than equal to 0. So we get X square minus 2X minus 3 greater than equal to 0. That is x plus 1 into x minus 3 greater than equal to 0. So x is less than equal to minus 1 or x greater than equal to 3. Problem 65 says that if a, b, c, d, p are real and a square plus b square plus c square in whole multiplied with p square minus 2ab plus bc plus cd multiplied with p plus b square plus c square plus d square less than equal to 0, show that abcd are in GP whose common ratio is p. So as the limiting case, we let d to be 0 because p is real. So ab plus bc plus cd whole square minus a square plus b square plus c square into b square plus c square minus d square is equal to 0. This has come because b square, that is this, minus 4ac, that is this, 4 has been taken out, is equal to 0. So from this we get b square minus ac whole square plus c square minus bd whole square plus bc minus ad whole square is equal to 0. That is b square is equal to ac, c square is equal to ad, bc is equal to ad. So this proves that A, B, C, D are in GP. Now we let R to be the common ratio. If R is common ratio, then P is equal to minus B by A because D is 0. So it is equal to AB plus BC plus CD by A square plus B square plus C square, which has been proven to be equal to R. So common ratio is P. Problem 66 says that if 2x to the power 4 is equal to y to the power 4 plus z to the power 4, xyz is equal to 8, and log of x with base y, log of y with base z, log of z with base x are in GP, show that x is equal to y is equal to z is equal to 2. So we have log of x with base y, log of y with base z, log of z with the base x are in GP. So we can say that 2 of log of y with base z is equal to log of x with base y is equal to log of z by x. So this 2 log with of y with base z will become log of y square with base z. So that is the square of the log here. It will go on y square according to logarithm. So we can say that log y by log z whole square is equal to log x by log y into log z by log x. Log x get cancelled out. Log y will come here and log z will go here. So log of y whole cube is equal to log of z whole cube. This log z square will go here. So y is equal to z. Now we know that 2x to the power 4 is equal to y to the power 4 plus z to the power 4. So 2x to the power 4 is equal to 2y to the power 4 because we substitute y is equal to z from here. So z becomes y. So this becomes y4 and y4 plus y4 is 2y4. So from this we can say that x is equal to y, and therefore we can say that x is equal to y is equal to z. Now x is equal to y is equal to z and xyz is equal to 8. So x is equal to y is equal to z is equal to 2. Problem 67 says that if ABCD are in both AP and GP and B is equal to 2, then find the number of such sequences. So we let R to be the common ratio. Since ABCD are in AP, B minus A is equal to C minus B. So A into R minus 1 is equal to AR into R minus 1. That is AR minus 1 into R minus 1 is equal to 0. So this implies that R is equal to 1. Therefore, we have one such possible series. If log of a with base x, a to the power x by 2, and log of x with base b are in GP, then find x. Here we take the square of middle term, that is a to the power x by 2 whole square is equal to log of a with base x, log of x with base b. So this will imply that right hand side becomes log a by log x by log b. So log x will get cancelled. It will be log a by log b, that is log of a with base a. So a to the power x is equal to log of a with base b. Now we take log of both sides with base a. So left hand side will become x and right hand side will become log of a with base b, and of that we take log of with base a. So that is the value of x. Problem number 69 says that the m plus nth and m minus nth terms of a GP are p and q respectively. Show that the mth and nth terms are square root of pq and p multiplied with q by p whole to the power m by 2n respectively. So here we take x to be the first term and y to be the common ratio, not difference. This should be ratio. So m plus nth term is equal to xy to the power m plus n minus 1 is equal to p, and t m minus n is equal to xy to the power m minus n minus 1 is equal to q. So we multiply both of them. When we multiply, we get pq is equal to x square y to the power 2 into, this should be in the power m minus 1. That is xy m minus 1 whole square is equal to tm square is equal to tp. So we conclude that this tm is equal to square root of pq. This should be tp, not tm. So now we substitute this in either of the formulas, or we divide simply. Then we get q by p is equal to y to the power minus 2n. That is y is equal to p by q to the power 1 by 2n. So now you can find x and tn. So this should be tm and this should be ratio. If pth, qth and rth terms of an AP are in GP, then find the common ratio of the GP. So hang on, let me see if I missed any problem. No, I did not. So this is 69 and then this is 68. Okay. So problem 70 says that if the pth, qth and rth terms of an AP are in GP, then find the common ratio of the GP. We let A to be the first term and D to be the common ratio. We also let pth term to be X and common ratio to be R of the GP. Then we can say that A plus P minus 1 into D is equal to TP is equal to X. A plus Q minus 1 is equal to XR. A plus R minus 1 is equal to XR square. So we subtract X and XR, we get Q minus P into D is equal to X into R minus 1. And we subtract here the Rth term and Qth term, we get R minus Q into D is equal to XR into R minus 1. So by dividing these two, we get R is equal to R minus P by Q minus P as the common ratio. That is what was asked. So with this, we come to the end of 7th set of problems. In the next set, we will solve 10 more problems. And if you have found this video useful and informative, please subscribe to the channel and like the video. And if you want to say something or if you have a comment or a suggestion, leave me a comment in the comment box and I'll try to reply to that and fulfill your demands. Thanks a lot for watching the video. Enjoy.